Let's see this question. We're given 4 points in 3-dimensional space. And so think about the 4 points in 3 space. Right? It's probably a little bit difficult to imagine it. So we are asked to find the volume spanned by or formed by these 4 vertices. So how do we see that? If we connect those 2 points, or connect those 2 points, we see we have 3 vectors. We have 3 vectors. 3 vectors, if they're not coplane, they will form a 3D objects like this. Let me see if I can draw it. So think about this is one plane, right? These 2 vectors span another plane. Also, this vector and this vector will span another plane. So somehow the picture probably will not be so good. But we see this. They will probably fall. Yeah, something like this, more or less. So they form 3 vectors not coupling spin 3-dimensional objects, so which we call parallelopiped. So how do we find the volume of that? So that's a determinant, idea of the determinant. So what are we going to do is we're going to find the 3x3 matrix and then find its determinant. So how do we find 3 vectors? Basically, 3x3, we have 3 vectors, right? So let's name an initial vector. Let's see, initial point. Let's see this point is 0, 1, 0. And this point is 0, 2, 0. And this point is 1, 1, 1. And this point here is hiding is 3, 1, 2. Right? Not exact, but just to imagine those as those. So because we're treating this as initial vector, so when we subtract this initial point, when we subtract each point from this, so we will get a vector of this, we'll get a vector of this, get this vector. So let's do this one. 1, 1, 1 minus 1, 0, 1. So we get 1 minus 0, which is 1. 1 minus 1 is 0. 1 minus 0, we get 1. So that's this vector. Right now, let's do this vector. So 0 minus 0 will be 0. 2 minus 1 will be 1. 0 minus 0 will be 0. Then let's see this vector. 3 minus 0 will be 3. 1 minus 1 will be 0. 2 minus 0 will be 2. Okay. So we want to find a determinant of this 3x3 matrix, which is the 3 vectors in 3 dimensions. So how do we find a determinant of this? Well, we want to work with the middle one, this row vector, right? Because the first entrance is 0, the third entrance 0, you only have to work with 1. 1 is in the position of the second column and the second row and second column. So 2 plus 2 is a 4 even number. That means it's positive. So we're going to do 1 times the determinant of 2 by 2 matrix. So where do we get those 2? So we cross out this. We're taking this 4 entrance. Find the determinant of this 4. So 1, 1, 3, 2. Well, 1 times anything would be 1. We can ignore this 1. Then determinant of 2 by 2 matrix. Remember, we multiply this entrance with this entrance. So 1 times 2 is 2. Let's subtract this entrance multiplied by this entrance 3 times 1, which is 3. So we get -1. But when we talk about volume, the measurement of volume won't be negative. So what do? We take an absolute value of this determinant. So take absolute value of it. And the absolute value of -1 is 1. So the volume of this object is 1. We just don't care about the unit at this time.